Here is Projectile Motion in Kinematics by Joe E. Ignacio. So just nailing down some quick definitions real quick. A projectile is a free body object, only subject to gravity and air resistance in the air. And we'll also see many projectiles, shot through a cannon, kicked, shot off a cliff. Yep. And important to note that the maximum is just the maximum height that it's at. We'll be dealing with a lot of finding the maximum and finding the apex. The maximum is also called the apex. Important to note. And one thing that influences the trajectory of the projectile motion is the angle. So this could be like different angles where it's shot off. And if an angle is vertical, 90 degrees, the component or the trajectory will also be straight up. So basically it's saying if it's shot up at 90 degrees, it'll go up 90 degrees. It'll just go straight up. And same goes for horizontal. If it's shot straight across, it'll just go straight across. And that's 0 degrees. And these are the things that affect trajectory: speed, the height, maybe it's shot off a cliff, and the angles that I talked about earlier. Alright, and important to also note that the optimum angle is 45 degrees for when it's landing, and if it's on a flat surface, that's for shooting up to, but for cliff, it's different. And then I'd say this little diagram thing is one of the most important things to really nail down. It's really important to see that horizontal and vertical are vector quantities and are independent of each other. As you can see, they go throughout. Horizontal actually never changes, but vertical is influenced by gravity, and yeah, horizontal is always the same. Also to note that horizontal does not affect how long it takes to get to the ground. So right here you can see that this white one is just dropped straight down, this one is shot to the side. However, gravity acts on each equally, and the horizontal velocity doesn't matter, they'll hit at the same time, as long as they're dropped from the same distance. And we'll just note that gravity equals negative 9.8 meters per second. I'll use negative 10 mostly for the examples later on. And then at the apex, v, the vertical component of velocity, is 0. Very important. That's how we're going to find our height at the apex and the time it takes to get to the apex. Very important to note that. And then basically, just starting off really simple, calculating the components of the velocity, v of x, v of y. This is really mostly just simple trigonometry. Gives you 23 degrees that it shot off, 3.2 meters per second. Use my cosine to find the horizontal. Use my sine to find the vertical right there. Just drew a triangle with the solid line, drew the dashed lines. That's how you find horizontal and vertical. Alright, get your notepads out because I would write these equations down. These can be written in different ways. This can be written as v naught, v final. This could be x. Many different ways to represent it. A lot of times we'll see this A as g when we're dealing with vertical, and that's just 10 meters per second, or more specifically 9.8. And yeah, you can plug horizontal and vertical velocities into these. And also note, not on here, that for constant velocity, velocity equals velocity, or x equals velocity times time. Here, I'll write that down. That's used mostly for the horizontal, because horizontal is always constant in these types of problems. So we're going to go in our first example. You can see right here, we don't know the height of the cliff. We know the horizontal component of velocity is 10 meters per second. Time it takes to hit the ground is 5. Don't know too much else. Going to try and find the height, the distance that it travels, and its final velocity, vertical. So start off easy. X equals vt. We know horizontal is always constant. So x equals velocity, 10 times the time, 5. So x equals 50. We know that this distance is 50. All right, and we know through our equations, we know h equals 1/2 gravity acceleration times time squared. We plug in what we know, gravity 10, time 5, get 125 for the height. Pretty simple, just plugging in equations right there. And then we get that for the vertical component of velocity at the end. Again, just simple equation, plugging that in. Final velocity equals gravity times time, 10 times 50, 15 meters per second. All right, that one's probably one of the more easier ones. Here is the last example and probably the more difficult one. You see we get a parabola shape. You can see they give us 53 degrees at 10 meters per second. Want to find the height in the middle. Like I said earlier, that's going to be where we want to know, identify the apex, and we want to know the time. So through trig, I kind of saved work and just wrote it down. V of x equals 6, v of y equals 8. And then we'll just flip it over here. Actually, we'll start with the vertical. So we know v final equals v naught times g plus gravity's acceleration times time. So we know that apex is 0. So we're going to do, that's going to be our final velocity. 0 equals 8 times 10t. Work it out. T equals 0.8 seconds for the halfway. That's how long it takes to get to right here. Simply just double it for the whole time throughout the whole thing. All right. So 1.6 seconds to go the whole way because it's 0.8 seconds halfway. Now we're going to try and find the height at the apex, right there, h. And h equals 1/2 gt squared. Plug in what we know, and it's 3.2. And we use 0.8 because we're only concerned with the vertical component. And then we'll flip it over here to horizontal, x equals vt. And velocity, and our x component, 6. Make sure you pay attention to the components. And 6 times 1.6 is our total time, equals 9.6, so it travels 9.6. That wasn't a thing that asked us to find, but found it anyway because we can. And that is all for projectile motion and kinematics by Ignacio. Thank you.